Today we're going to talk about the logarithmic function. So the first thing that you need to know is that it is the inverse of the exponential function. So an exponential function could be y is equal to 2 to the x, so the exponent has the variable, and the logarithm would be y is equal to the log base b of x. I'm going to write the proper verbiage underneath here. So how you say the logarithm is log base b of x. So in this case, the b is going to be the base, which is a 2. The exponential of 2 to the x has an inverse, which is the logarithm base 2 of x. So we need to know how to convert back and forth between exponentials and logarithms. In this video, we're just going to do a lot of rules and then we're going to apply those to our learning. So below it says that we have the log base 10 of x is equal to y. And if we're going to rewrite this as an exponential, the base of the logarithm is also the base of the exponential. So we have a 10, so I'm going to write 10. Then the y value is going to be the actual exponent, and then it's going to equal x. So one way to think about this, I call it the crisscross. So we have the 10, we cross over to get the exponent, and then we cross back, and that's what it's equal to. 10 to the y is equal to x. So a logarithm is used to help solve for an exponent. Another way to remember how to change a logarithm into an exponential is this phrase, slide the base, drop the log. So let me show you that. If I slide the base over, it becomes the base on the right-hand side, and then if I drop the log from the original, then I'm left with 10 to the y is equal to x. So the same answer that we had when we just did the crisscross method. So let's try that below. If we slide the base, it becomes the base on the right-hand side, and the y is now the exponent, and we drop the log. So this gets rearranged to be the base of b raised to the exponent of y is equal to x. So one really important rule is that a base is always a number greater than 0. You can never have a negative base, and you also cannot have a base of 1. Another rule is that our x value is always going to be greater than 0 as well. The next example we're going to look at is what we call the natural logarithm. That means that the base is the number e. So if we convert from our logarithm to our exponential, we're going to slide the base, drop the log. So we get e to the y is equal to x. Now instead of writing log base e, there's a shorthand. So log base e is actually equivalent to an L with an n next to it, ln. So what's important is that you recognize that, so when you see ln x, that is our natural logarithm, so in your brain you have to remember that it's really a logarithm. It's a fancy way of saying the natural logarithm. So these two lines are equivalent to each other. So if you can convert from a logarithm to an exponential, then you can convert from an exponential to a logarithm. So the base of the exponential is 2. So that means that the logarithm base is also a 2. And remember our crisscross method. So we have the x next to the 2, which is equal to y. So remember, a logarithm is used to solve for an exponential. So the exponent on the exponential form will always be the solution to the logarithm. Now below I've written some very commonly used properties. Now you do not need to memorize these. I encourage you not to memorize them. If you understand how to convert exponentials to logarithms and logarithms to exponentials, then you will be fine. So let's look at this very first one, just so we can practice. It says log base b of 1 is equal to 0. So we're not very familiar with logarithms. Our minds are more adept to thinking about exponentials. So if I change this to an exponential, b to the 0 is equal to 1. Well, when you learned about properties of exponentials, you learned that anything raised to the exponent 0 is equal to 1. So that means that this property makes sense. I'm not sure what I did here. I think I just went a little bit crazy. Let's go to the next one. Log base b of b is equal to 1 doesn't mean too much to me right now, but if I change it to an exponential, the base of b raised to the exponent of 1 is equal to b. Well, that actually makes sense. Anything to the exponent 1 is itself, so that means that b is equal to b. That is a true statement. Now let's look at the natural logarithm. So really this is our fancy way of saying log base e. So the ln is equivalent to log base e. Then this e is right next to it, which is equal to 1. So this e refers to this one. So let's look at this again. If I change this to an exponential, I have the base of e raised to the exponent of 1 is equal to e. Now, what do you notice about these last two examples? So what I want you to notice here is that anytime you have the same value right next to each other in a logarithm, they always simplify to be 1. So we have an e and another e, it's equal to 1. We have a b and another b, it's equal to 1. So another example could be log base 4 of 4. That will equal 1 because these two numbers are the same. How we prove that is 4 to the 1 is equal to 4. That is a true statement. Take some time and go through the remaining properties. Hopefully you're getting a handle of the pattern. Now the last two are kind of interesting, so let's talk about those. Here we have a base and we have an exponent. In that exponent is the logarithm. This rule is that anytime you have a logarithm inside of an exponential where the bases are the same, they cancel. So for example, if I have 4 log base 4 of 3, that's going to equal 3. That's because the base of 4 for the exponential is identical to the base in the logarithm. The exponentials and the logarithms are inverses of each other, so therefore they cancel each other out.